This is problem 109 of Neetcode 150, longest increasing subsequence. All right, so we are going to be given an array of integers like nums, and we have to return the longest subsequence of increasing numbers. So let's see why here in the array nums, the longest subsequence of increasing numbers is 4. Because if we take a look at this, we might ask like, what is even a subsequence? Well, let's take a look at this example here above. So cat is a subsequence of crab, because if you take every single characters inside cat and you take a look basically at the order in which these characters appears in the other words crab, well, these are exactly the same. It doesn't matter if there are other characters between these, as long as they appear in the same order. So as long as there's a C, a A, and a T, and as long as the C appears before the A and the A appears before the T. So if we take a look at nums and we apply the same concept, we see that the 1 itself um, is smaller than 4, but then the 4 is greater than 2. So if we take a look at this holistically, we can see that 1 is smaller than 2, and 2 is smaller than 3, and 3 is smaller than 7. So the longest subsequence will be 1, 2, 3, and 7. If two numbers are the same, that doesn't work. So you can just take 2, 3, and 7. That will fail because the numbers that follows has to be greater, like strictly greater, can be equal or greater. So let's see how we will solve this using dynamic programming. So this is our array of numbers. So what is the longest substring that we can find here? So we can find 1, then 2, then 4, then 8. So this is 4. Okay, not bad, but can we actually do better? Well, let's take a look at this. So what if we start at what if we start at 3? So we take the 3, we take the 5, okay, we take the 8. So this is 3, so we didn't do any better. Okay, so I'm pretty sure there's another solution that is more efficient than 4. So let's take a look at this again. Let's take our 1, let's take our 2. But instead of taking our 4, let's just go take our 3. Let's take our 5, and then we can take 6. Yeah, that works. So now this is 5. This is greater than 4. So the longest subsequence of increasing numbers inside this array will be 5. And notice also this little trick here. At 6, if we just start at 6, what is the greatest subsequence of increasing numbers starting from the last index? Well, it is obviously 1, right? What if we go to 5? Well, you can do 5 and 6, so it is 2. And what if we go to 3? Well, obviously the two numbers that follows are greater. So the greatest substring of, the greatest for a substring of increasing numbers starting at 3 will be 3. At 8, it is 1, right? Because there is no greater number after this. But at 4, it is 2, because you can take 2 and 4 respectively, and you will have a greatest, you will have basically a greater number. But let's take a look at this, because 4 is smaller than 5 and 6. So you can just take, basically, you can take 1, you can take 2, you can take 4, and then 5, and then 6. And that will also give you 5. So starting at 4, we have to say that the greatest substring of increasing numbers is also 3. And now at 5, what is the greatest substring of increasing numbers? Well, you can take 5 and 8, or you can take 5 and 6. In both cases, you have 2. And starting at 2, well, you can take 2 and 5, and then 8. So this is 3. You can take 2, 4, 5, 6, right? So this will be 4. And you can take 2, 3, 5, and 6, and this is also 4. So we can write 4 here. And now at 3, we can take basically 3, 5, 8. You can take 3, 4, 5, and 6. So the greatest substring of increasing number is 4. And starting at 1, you can take 1, 2, or you can also start with 1, 3. And you know that if you continue at 3, you're going to have basically um, a substring of length 4, right? So basically what we want to do is that we just want to check all the other numbers to the right and see if their count, well, see first if that value is greater than that current value we're at. And if it is greater, we want to see its count. And we want to see if its count is greater than basically 1. And if it is, well, we just want to add 1 to this. So it's going to be 5 like that. And at the end, we can just return the maximum number among all these values. This is going to give us the greatest substrings inside our array. So let's go ahead and code this. So what is the first thing that we want to do? Well, we want to create basically a certain value for all the numbers. So I will say initially that each of these will be equal to 1 because a number itself can be considered as a subsequence of 1. So we know that if we're not given an empty array, we're at least going to have an answer of 1. It's going to be times the length of actually it's called nums. Right, and now we're going to go in a reverse order. So we're going to say for I in the range of the length of nums minus 1. So we reach the last index and we want to go up to the index 0. So the bounding index is going to be minus 1. And you want to go in a reverse order, which is why we were placing in minus 1 here. And now we're going to go see all the other numbers to the right. So I will say for G in the range of I plus 1, right? We want to take another number to the right. So for G in the range of I plus 1 up to the length of the nums, I want to check first if the number that I currently have, so nums at the index I, is this smaller than the nums at the index G? If it is, well, we want to make sure that the dp at the index I, well, I said sp, I want to say dp at the index I, it's going to be equal to the maximum between, well, its current value, so dp I, and also 1 plus the dp at the index of G. So that we're going to go for, let's say at 1. At 1, if we don't know yet what is the greatest value, well, we know that initially this is set to 1, right? Because we basically create value 1 for all the numbers inside the array. And we're just going to go see all the others inputs, all the other numbers. And for all of the other numbers, if that value is greater than the 1, which is the case for all of these, we want to take basically if I can take that number plus 1 and have something greater than what currently is there. And what currently is there is 1, so it won't be hard to beat. Right, so it appears that the greatest value is going to be 4 plus 1, so it's going to be 5. So this is why we have 5, because we know that basically starting at the other positions, we're going to have the longest substring, or subsequence of numbers, of increasing numbers, equal to that value that we set it to each of them. So we know that if we go from 1 to 3, well, we know that starting at 3, we can have exactly 4 numbers that are increasing in a subsequence, right? So this is why we have 5 here, because we're adding that number 1 to this subsequence. So now we have 5 instead of 4. All right, so yeah, after this, what do we do? Well, we were just going to be willing to return the maximum value inside the DP. So that's it. So if we submit this, it works. Great. So notice that in terms of space complexity, we are creating DP here, which is exactly the length of nums. So we're going to have a big O of n for the space complexity, where n is the length of the nums. And for the time complexity, well, we're going for every single number inside the array. And for every single number, we are going to go for all the other numbers. So we're going to go for n times n, so n squared. So the time complexity is going to be big O of n squared, because we're going to go basically for every numbers at every numbers, right? So with that being said, I hope you enjoyed the video, and I hope to see you in the next one.